Okay, so in this section, we're going to be actually solving word problems. So we're going to have to set up our own formula for the function, then find the derivative, then find the maximum and minimum. And so in this picture, or in this example, we have a cardboard box and we're going to be cutting corners off. So we're going to be cutting these corners and then like taking them out and then folding the remaining corners to make a three-dimensional graph or a three-dimensional picture. And this is going to be some sort of a box, and the question is how much of each corner should I cut off so that when I turn it into a box, the box will have the biggest possible volume. Okay, so that's the question. What dimensions will yield a maximum volume? So we're looking for the maximum volume. So we want max volume. Now, hopefully you remember the formula for a volume of one of these boxes. If you don't remember, it's not terribly difficult. For volume of a box, it's pretty much gonna be the length times the width times the height. Okay, so length times the width times the height. And so in this particular example, let's say this represents the length and the width is gonna be maybe possibly that one right there. And finally the height is gonna be, let's say, this side over here. Okay, and since the box that we're making is squarish at the bottom, it does not matter who the length and who the widths are. So I'm gonna make a formula. The volume in this problem is gonna depend on the letter X. That's the letter I'm seeing in all the pictures. The length is gonna be 8 minus 2x, so I'm gonna write that down, and the width is gonna be 8 minus 2x again. I'm gonna write that down, and the height is automatically x. I'm gonna go ahead and write it down. Okay, so there we go. At this point, we would need to find the derivative in order to find the maximum volume. We need the derivative and we need to know the critical numbers. And to do that, it may be a little bit easier for me to just FOIL everything. So I'm going to go ahead and multiply everything out. So I'm going to go 8 times 8, 8 times 2, and so on and so forth. And at the end, I'll multiply with the x. So let me fill in the answer. So that's the product of the inside, and at this point I'm just gonna go ahead and multiply the x over everything and see what I get. Okay, so there we have it. That's the volume formula, and remember we're looking for the maximum volume, so we would need to find the derivative because the derivative tells us the maximum and the minimum. So let's go ahead and write down v prime of x. The derivative of 64x is gonna be 64. The derivative of 32x squared is gonna be negative 64x. And the derivative for x cubed is going to be basically 12x squared. Okay, so now that we have the derivative, we're going to look for what makes it equal to 0 and what makes it undefined. So v prime of x is equal to 0 when the 64 minus 64x plus the 12x squared is equal to 0. And you know what? Let's divide the numbers by 4 to make life a little bit easier. We can do it since we're doing it to all sides, and since we're doing it to everybody, it stays balanced. So dividing by 4, what do I get? Let's see. So I get 16 minus 16x plus 3x squared, and eventually I need to factor this and find out what makes it 0. So maybe it's beneficial for me to write down the 3x squared first, then the 16x, then the 16 equal to 0. And let's see if we can factor this, or maybe use the quadratic formula if we cannot factor. Okay, so with some trial and error, I was able to factor the 3x minus 4 times x minus 4. And you should take some time to double check this and make sure that it's actually right and that it actually works for you and you know how to get this on a test. So in any case, what makes this equal to 0? What makes it equal to 0 is going to be 4/3. And what makes this one equal to 0? The number has to be 4. Okay, so those are so far the two critical numbers. And keep in mind that the v prime cannot be undefined. So v prime of x undefined is not going to happen. This is not even possible because the derivative does not even have a denominator. So now we've got to basically figure out who's max and who's minimum in this problem. In order to find out who's max and who's minimum in this problem, we have to go back and kind of think about what does x represent in this problem. X represents the amount that you're cutting off, right? So it's the amount that you're cutting off. So now, remember, the whole box is 8 inches. So can you cut off, like, let's say 7 inches from here and 7 inches from there? That does not make sense because the whole box is 8 inches in total. So if you cut 7 inches, you only have 1 inch left. How can you cut 7? So the maximum amount you can cut is maybe 4 inches, and that really is not realistic either. So, what I'm trying to say is that down here, 4 was one of the critical numbers, but it won't make sense. As a matter of fact, when you draw the v prime line, you're not going to draw negative infinity, positive infinity anymore. Instead, what you want to do this time is make your line start with 0 and end with 4. Why are we starting with 0 and ending with 4? Because we cannot cut off less than 0 inches. 0 is the minimum. That's when you leave the card box alone. And you cannot cut off more than 4 inches because you don't have enough, right? The whole thing is 8. So if you cut 4 from the left and 4 from the right, there's no more box left. So that's the reason why we're putting 0 and 4. And 4/3 is the only critical number. So let's pick a number before and pick a number after and see what happens. So if you pick a number before, 4/3, 4/3 is roughly 1.3. We can pick 1, and let's pick a number after, let's say 3. Put them into the derivative and see what we get. So 1 gives me a positive amount, and 3 gives me a negative amount. So the max volume happens when x is equal to 4/3. So this is the absolute in this case, max. Why is it absolute? Again, because it's the only critical number of the problem. Okay, the other one got eliminated. So 4/3 is the amount that you have to cut off in order to get the maximum amount of volume. Okay, so what dimensions? Well, let's go back and find out. If the x itself is 4/3, how much is 8x minus 2x gonna be, and how much is 8 minus 2x gonna be? So let's investigate by putting 8 minus 2 times 4/3 into the calculator and getting the result. Okay, it turns out that 8 minus 2x is gonna be 16 over 3. So those are the numbers that will maximize the volume of this box that we're working with. Okay, so those are the numbers, and the question now is, well, how much is the actual volume gonna be? Let's go ahead and multiply them together. So how much is 4/3 times 16/3 times 16/3 again? What would the maximum amount of volume be? So put this in your calculator and let's see what we... Okay, so I'm getting 1024 over 27 cubic inches, which is roughly speaking, let's say 38 cubic inches. So it's actually 37.9 something something something, but who cares? This is the maximum volume. Okay, so they want us to find the maximum volume, and we did, and we found it by searching for the amount that needs to be cut off.